Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 70, climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distant way can you climb to the top? For example, if n is equal to 2, you can go with 1, the first staircase and the second staircase to reach the top, or you can directly go to the 2 steps, which means to the second staircase, right? For example, n is equal to 2 means you have like this 1 and 2, and you are standing initially here. You can either go like this, so this is one of the way, or you can directly take 2 steps and reach the top. So this is another one unique way. So there are 2 ways, so 2 is going to be the output. Similarly, now n is equal to 3, then I can go here, okay, then again here, then here. So all the things will be 1 step, or I can take 1 step then 2 steps, okay, or I'll be taking 2 steps then 1 steps. So totally there are 3 steps, okay. So 3 is going to be the output. Similarly, for 5 we have 8 steps, okay, fine. So what is going to be the logic behind it? So the logic is so simple. See here, whenever we are standing at a particular point, we want to go either 1 or 2, which means all possible combinations. Whenever there is all possible combinations or 2 or 3 combinations, then we want to go for a recursion. In recursion, always remember this. Whenever we are taking a recursion for something, then always prefer top down, okay, top down, because this will be helpful. What is meant by top down? If I start from the topmost value, the resultant value, then it is going to be the top down. If I going to start with the bottom up, then it will be here. So always try to start from the top down. If there is no such case, then start with bottom up, okay, because when we are starting from top down, from the result to the 0 or the lowest point, then it is useful to when we are just converting it into a optimized version, okay. So initially here I am standing, okay, at the final point. I can either go to here or I can go to here, right? So I have two choice. Either if it is n, I can go to n minus 1 or n minus 2. Similarly, for all others also, I can either go to here or I can go to here. So for all others also, when I am standing at particular point n, then I can go for n minus 1 or n minus 2. Okay, such that they will be reaching the end part. Cool. So this is going to be our approach. Right? Can you understand this? So what is mean recursion? Recursion means we have a big problem. We want to solve them into some finite problems or sub problems, okay. Still that sub problems can be simplified as much as further, okay, until some sub problem cannot be divided into further sub problem. We can directly give the solution. Up to that we want to traverse, right? So here what is your understanding on the that minute sub problem or the base case? That minute sub problem that cannot be divided much more further, that giving directly the solution is called the base condition. So here what is going to be the base condition? This 2 and 1, because for this 1 I can tell you only one way we have. For this 2 we have either like this or we can go directly like this. So 2, can understand this, which means when I call the function for 1, it will be returning 1. When I call the function for 2, it will be returning 2. So these 2 are going to be my base condition. So these cannot be solved further. So these 2 going to be my base condition, okay. And now let us construct the function. So how my recursion function looks like? So function inside, what should be my parameter? My parameter should be what is the current staircase number we are, right? So let us take that as I. So this is going to be important. Like first I'll be starting from 5, okay. From 5, where all I can go? I can either go to f of 4 or I can go to f of 3, n minus 1 or n minus 2, right? As you already know, recursion will be always DFS. It is not BFS. So first you want to finish one recursion call to its depth, then come to the next recursion call, which means first finish this f of 4. Okay, so further this f of 4 will be classified into two. One is f of 3, which means n minus 1. Another one is n minus 2. Okay, again this f of 3, first finish this f of 3, then come to f of 2. Okay, so this f of 3 will be f of 2 and still classified as f of 1. Now complete this f of 2, then come to f of 1. But this f of 2 is answer is what? 2. That's going to be the base condition, right? So from this I can return okay, 2 is my return value, and then now go to this point. So here what's the return value? It is going to be 1. Okay, now sum up these two things. So what are the two? If I sum these two things, what is the answer? 2 plus 1 is equal to 3. So I can tell you, if I am standing at a staircase 3, then my result will be always 3. Can you understand this? That's what we have seen here. What is the output? It is 3. Can you understand this? So that's the reason why here also it is f of 3 is returning what? 3. How? 2 plus 1 is equal to 3. Now go for this f of 2. Here it will be returning f2. Okay. Now this will be returning me 5. Now go to the next depth, next recursion call depth. So again here it will be calling f of 2, and this f of 2 will be returning what? 2. Again it will be calling f of 1, and this f of 1 will be returning 1. So 2 plus 1 is equal to 3. So it will be returning 3. Now 5 plus 3, which is equal to 8. So this function will be returning 8, which is going to be my output. Can you understand this? Now tell me, what is the time complexity? So time complexity will be O of 2 power n, and space complexity will be O of n. And many of them will be having a doubt on this time complexity and space complexity analysis, isn't? So the time complexity here 2 power n is because for each and every function we have 2 function calls. Then for n functions it will be 2 power n. Yes. Now what is the space complexity? It is O of n. Many will be having one of the doubt is why it is O of n, because we haven't taken any auxiliary space. Another one doubt is why it is not O of 2 power n. So the first answer is why it is not O of 1. The constant is, see here, whenever it is going for a recursion, whenever you are going for a recursion, inbuilt itself there will be a recursion stack. Okay, always that recursion stack will be consumed. For that recursion stack only we are getting a auxiliary space of O of n. Okay, if you don't know about the recursion stack, I'll be giving the recursion introduction video link in the description. Just go and watch it so that you can understand how the recursion stack works. Okay, fine. Now the second doubt, why it is O of not O of 2 power n. See here, it is depth first search, which means it will be going down. Now what is the length of the stack? It is 4. When I come back and go here, this will be deleted from the stack. This will be deleted from the stack. Now when I come back, this also deleted in the stack. Now what is the stack length? It is only 3. Now again I will be going here such that it will be deleted. Then only I will be going here. Can you understand this? Now also it is 3. Now when I go up, this will be deleted. When I still go up, this will be deleted. Can you understand this? So this is how the recursion stack works. That's the reason why my space complexity is O of n, not O of 2 power n. Because it is a DFS. Again I am telling this. Always the recursion is a DFS, not a BFS. It is a depth first search. Goes up to the depth, reaches the depth, then comes up. Okay. Now let us see the code for this. Then we can come back and see how to optimize it. So see here. So this is going to be the code. First of all, I'm just it is the given function they want us to write. Okay, here I'm returning the helper function value. Sorry. Yes, here I'm going to return the helper function value. Now inside the helper function I have gotten a parameter as I. Now I'm just checking whether I is less than or equal to 2. This is the base condition. If it is 1, then I want to return 1, or if it is 2, I want to return 2. For that reason only I have put the condition as I is less than or equal to 2, then return I. Okay, then or else what should I return? I will be returning, hey, go to the function call of I minus 1, plus go to the function call of I minus 2 and add them and return it. That's it. Can you understand this? So this is going to be the recursion code. Now we are going for an optimized version of this recursion code. So this is going to be the first approach. Okay, the recursion approach. Now we are going for a optimization. Okay, whenever there is an optimization, we want to think about the memoization technique. So memoization can be done via two things. One is hash map and another one is array or matrix, depending on the number of dependable variable in a parameter. So basically the terms only bit like a very huge term, but inside that the logic is very simple. Okay, don't scare of seeing these terms. Okay, fine. So see here if you observe this carefully, f of 3 is occurred here. Again this f of 3 is occurred here also, but here itself we know the answer of f of 3 is 3 when I am going here itself. But still again if I encounter f of 3, again I am going down. So from here I can understand if in advance when I first reached this f of 3 and found out its answer as 3, if I stored in my memory like, hey, whenever I value is equal to 3, just return 3, don't go further, then I can call it as a optimization. Can I understand this? Yes, for that we are going to use a hash map. If I use a hash map, then whenever I have found that f of 3 is equal to return value is 3, then my key value going to be I and the return value going to be the value, so 3. Now f of 4 is returning what? 5. 4, 5. Now again when I go for this f of 3, first I finish these things. Then only I go for the next recursion call, right? So when I encounter f of 3, further going down, instead I'll be directly returning 3 by seeing into the hash map. Can you understand this? So in my optimized version, if I use a hash map, then my time complexity will be O of n log n and space complexity will be O of n. Okay, if I use an array, then you want to know some things, because using the hash map is much easy, but using the array is quite difficult. See here, not difficult but not easy as much as this hash map. Okay, now what is the varying factor here? Only I. Okay, and what are all those values of I? It may reach up to 5. Then you want to take an array which contains up to 5 in this 0, 1, 2, 3, 4 and 5. Okay, now initialize everything with some values that doesn't occur in this function. 0 doesn't occur in this function, -1 doesn't occur in this function, because see here any return value is equal to 0 or -1, no, right? So you can take any values which are 0, -1, -2, that's your wish, but it should not be occurring in the return values like this. You cannot take 2 or 1 or 3 or 5 like that. Okay, so here what is going to be my answer? What is going to be the initialization value is, I will be initializing easily like 0, 0, 0, 0. Okay. Now whenever I encountered some values and found it, so f of 3 is returning what? 3. So I'll be just changing this as 3. Now f of 4 is returning what? 5. So change this to 5. Now again when I go for this f of 3, I'll be checking whether my third in this element is 0. No, it is not 0, which means it implies, hey, it is already computed. So you want to don't go further, just return 3 there itself, because the value of the f of 3 is 3. Can you understand this? So this is going to be the memoization using array. Okay, by doing this my time complexity will be O of n, meanwhile my space complexity will be O of n. You may ask, hey, how the time complexity is going to be O of n? Because there are totally of 5, 4, 3, 2 or either 1. So there are totally of n terms, n function calls. Apart from that, if there is any other function call like this, then I'll be taking the value from here and giving here. So which means accessor time of array using the index is going to be O of 1. Okay, and just think about it. We are only using n values to find out. That's the reason why my time complexity is O of n and space complexity is going to be O of n because of array plus recursion stack. So these are the two factors that are affecting this. Okay, now I want you to do this by yourself. Okay, and for this array I will be giving you the approach. Okay, fine. So see here, let me comment this out. Yes, so see here, this is going to be the array approach. First of all, everything is similar here also. Here I'm just taking one line to initialize that array as n plus 1. If n is equal to 5, then I want 6 size. That's the reason why I'm taking as n plus 1. And here I will be checking the same base condition, but here another base condition is if that particular I value, that ith index is not equal to 0, which means it is already computed. Whenever it is already computed, I will be returning that index value. Can you understand this? And then before returning this result, I will be storing that result in the ith index. Then I am just returning its particular result. Can you understand this? So this is going to be the memoization code. Now let us copy this memoization code and convert this memoization code into a tabulation. Now the next approach is tabulation. So tabulation is like, see here. First understand what is the purpose of tabulation. Here, why we are getting a space complexity of O of n? Because we are using a recursion stack and the array. If I cancel out this recursion stack, then one burden is completed. So to cancel out this recursion stack, what I am going to do is I will be converting this code into a looping format. Recursion code into a looping format so that this will be eliminated, obviously. So tabulation we will be doing in a way like, if in recursion we used bottom up, okay, then in tabulation we are going to use top down, and vice versa. Whatever it is used, we will be doing a ulta or a reverse format. Can you understand this? So by using the code, you can understand this clearly. Let me take the code. So here, this is going to be the code. Okay. Now listen this. Now same array is also going to be initialized here also. So what is that array? The array of size 6. Okay, if n is equal to 5. Okay, then this is going to be the array. Now what the small difference I am going to do is, here where my function starts, the function starts at n and ends at 0. Now ends at 2, because my I is lesser than or equal to 2, then I will be returning the value, right? So initially I will be making all the values in my array as 0 initially. And the second step is, see here, if I is equal to 1, then what should I return? I will be returning 1. So make my first index as 1. And if I is equal to 2, what I return? 2. So make my second index also to 2. This is going to be the second step. Now what is the third step is converting into a looping. So far I'll be using pseudocode, not the Java code, okay, to make all to understand this. Okay, now I'll be taking a for loop, and I will be from 3, okay, up to what? Up to n plus 1, or n up to n, which means I will be going up to this particular value. Okay, so this is going to be the looping. Okay, inside that, what I am going to do, take this line and write here. So memo of I is equal to, instead of this helper, replaces memo of, what is the changing parameter? I minus 1, right? I minus 1 plus memo of I minus 2. That's it. Can you understand this? By doing this, at last I'll be returning what? I'll be returning memo of 5. Why I'm returning a memo of 5? Here also I'll be returning what? Return helper of 5, right? That's the reason why instead of this helper, I'll be replacing as memo. Can you understand this? So this is going to be the overall code. Can you understand this? That's it. That's it. It is going to be the overall code. And now also my time complexity will be O of n, but my space complexity have a slight difference. Like here, this O of n is because of the array. Because of the array. Can you understand this? So let us see the code. Then we can continue the rest of the approach. The next approach is space optimization approach. Okay. So first let us complete the code. So see here, this is going to be the code. First of all, I am checking whether n is less than or equal to 2. Then I will be returning n. So this is going to be the first condition. You may write this condition or you may ignore this condition also. That's your wish. If you ignore also, it will be running successfully only. Okay. Now here I have taken as dp. Instead you can take memo whatsoever variable. Here I have taken that as dp. Okay. Now this will be same. See here, compare here. This will be same. See here also memo is n plus 1 and here also memo is n plus 1. Okay. Now what is going to be the return value here? When I is equal to 1, I'll be returning 1. When I is equal to 2, I'll be returning 2. Same here also. I'll be initializing them. Okay. Now I'll be starting from 3 and going up to n. Up to n. Okay. Now here, what I written here? Memo of I is equal to, instead of this helper, I replace as memo. And what is the changing parameter? It is I minus 1. Similarly here also. That's the same line I written here. Can you understand this? At last, I'll be returning dp of n. Because here what I am returning? Helper of n. I am returning helper of n. So similarly here also dp of n. That's it. That's it. Simple, right? So this is going to the tabulation code. Let me submit it. Okay. Here there is a edge case. Okay, fine. So what is the edge case is if the size of the dp is 1, okay, then we don't have this dp of 2 in this, right? Second in this is not available. So that particular condition we will be encountering. So that reason you can add this edge case. Okay, for encountering that edge case, we can add this condition. Let me submit now. Yes, it is accepted, right? Now let us get into the next approach, space optimization approach. Let me copy this. Go here. Now it is space optimization, right? In space optimization, in previous approach, we have a space complexity of what? O of n. So for that reason, we are going with the space optimization. Okay, fine. So let us go. What is the last approach? 3. Now it is 4. Space optimization. Okay. Now in the space optimization approach, I'll be checking whatsoever space we need, whatsoever space we don't need, and eliminate those don't need spaces. Like for example, here for dp of I only want dp of I minus 1 and dp of I minus 2. I don't want whole thing. Can you understand this? For example, if I have like this 0, 1, 2, 3, 4, 5. Okay. For this second index, for this third index, I only want its 2 previous things. I don't want anything apart from that. For this fourth index, I only want these 2 things, 2 and 3 alone. So from this, I can tell you that we want only 2 sized array or 2 variables. You understand this? You can either take 2 variables or you can take array of size 2. Okay, I will be taking 2 variables. So one variable will be denoting dp of I minus 1 and another variable will be denoting dp of I minus 2, or else I can take the array of size 2 itself. That will be going to be more clear for you. Okay. Now initially this will be 1 and this will be 2. So I will be taking dp of 2. Now same thing. In dp of 1 I will be applying 1 and dp of 2 I will be applying 2. I will be inserting the value as 2. Fine. Now similarly here also I will be just taking my I value and traversing from 3 traversing from 3 up to n. Okay, inside that, what I am going to do, I just take dp of I is equal to dp of 1 plus dp of 2. These steps are same, but the only step we are going to differ is we are going to swap it, which means update it. So here dp of I, instead of this dp of I will be replacing this with some variable like temp. Okay, temp. Now listen this carefully. dp of 1 is equal to dp of 2 and dp of 2 is equal to temp, which means when my I value is 3, so here temp will be storing what? Temp is equal to dp of 1 is 1, dp of 2 is 2, which is equal to 3. Temp is carrying 3. Now I will be swapping my dp of 2 to 1 and dp of 2 as temp. Can you got it? So this is the value of dp of 2 and 3. dp of 2 and 3. So here what are the values going to be replaced? 3, 2 and 3, right? So that similar value is replaced here also. In I is equal to 4, what is my temp? Temp is going to be dp of 1 is 2 plus dp of 2 is 3, which is equal to 5, which means again this first term will be replaced as 3 and the second term is replaced as 5. That's it. Can you understand this? So this will be repeated again and again. If I want to give you using the variable, we can also use the variable as, like, see here I am using the variable. First of all, I will be taking a is equal to 1 and b is equal to 2 initially. Okay, now these for loop condition will be same. Now here temp is equal to a plus b. Okay, now a is equal to b and b is equal to temp. That's it. So this is code which is equivalent to Fibonacci series. Can I understand this? So this is how we want to just optimize our recursion code. Okay, initially we have taken a code of time complexity 2 power n and space complexity of O of n. Now for this approach, what is the time complexity? It is O of n and space complexity is O of 1, because we haven't taken any auxiliary space. We are only taking what? A and b. Now hope you understand how we optimized 2 power n into n. Yes, now let us see the code so that it will be more clear. We comment this out. Okay, now come here. Everything is similar to it. The only thing is I am taking two variables. Here I have taken like previous 2 as 1 and previous 1 as 2. Okay, now I will be starting from 3 up to n. Now I will be taking the current value as previous 1 plus previous 2, and I am updating my previous 2 as previous 1 and previous 1 as current, similar to my drawing explanation. At last I will be returning what? Previous 1. So this I forgot to give you, right? So at last, what should be my return value here? Here, what is my return value? It is dp of n. dp of n means the last index. Here, what is the last index? So if I have a and b, what is my last index going to be? It is b. So here I will be returning b. That's it. Can you understand this? So this is the entire approach. Now let me submit this. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video, subscribe to my channel. And if you have any doubts, just comment below. I will be commenting the answers. Thank you.